Okay, let's get started today. One announcement, I will not be holding office hours this afternoon. I have to take off right after class, so I can answer questions after class, but I will not have office hours from 3 to 4 today. If you have a question, can't ask it after class, you can post it to Piazza, and I will try to answer it late this evening. So I'll be in transit most of the afternoon and evening, but should be able to respond later this evening to questions. Also remember to do the quizzes. There's one, they are timed, so once you start the quiz, you have to finish it within the allotted time, and that's to just keep you from kind of going through your notes. I want you more to have some familiarity with your notes when you take the quiz, so that it's more rehearsing the information that you just learned. Also, after today, you can start working on the first homework assignment, so may want to get started on that. Finally, you should have gotten your database. If you did not, or a email about your database, its name, password. If you did not, then you will need to contact the IT staff, because that probably means you were a late addition to the class and they didn't have your ID, net ID, when they were setting them up. So you can write to the IT staff about that. I would suggest you change your password. Obviously, you get a pretty secure password, but pretty easy to change it. And if you look at my says for today, 8:30, if you look at getting started with your MySQL database, then it tells you how you can invoke the MySQL interpreter. I know it comes up, it says MariaDB, but it is an MySQL flavored database system. If you're wondering what these things mean, the -H gives the name of the database server. So in this case, it's dbs.eecs.utk.edu. So you need to provide that with the MySQL command so it knows where to locate your database. Then the P asks to have it, just a second, have it interactively prompt you for a password. Then you give the database name that you will be invoking that password on. Finally, your username. And you got all that information in that email, or should have. So then, first thing I always do, this is the command for setting the password to something that's probably a little easier for you to understand. And then if you actually just copy and paste this command into the MySQL interpreter, it will create a number of schemas for you that actually I will be using today. So I'll talk about that in a moment. But the source command indicates that you want to execute a file, in this case create db.sql, that has a number of SQL commands in it. So when you actually invoke the MySQL interpreter, so it prompts you for a password, and then it's actually just a command line interpreter. So you can either type SQL commands into the command line and have them execute, or more likely, I mean, when in a real system, you'd connect to it through a scripting language like PHP, Python, JavaScript, and you would execute the commands through the scripting language. You can also create a file of SQL commands, which is what I did normally. The prefix, or I'm sorry, the suffix should be .sql, indicates it's a .sql file with SQL commands in it. So question, I had a question. If you could do what?
Like a key pair, or do anything, just so we just have to type in the whole MySQL, the command login.
you can alias it, but other than that, I don't know how to do it. So you could, if you're familiar with aliasing in the shells, you can create a simpler command that will do it. You can also, I'm fine with you setting up your own SQL server on your home machine. Sometimes that's easier in terms of connectivity. Obviously, you don't have to be connected to a wireless net when you have it locally. Just make sure that when you submit your homework assignments, it runs with the MySQL interpreter that we have here, because that's what Elvis will be running it against. And as you can see, it's running it on a slightly different flavor of MySQL. They're using the MariaDB. So you need to make sure that whatever you write actually works in the same way here at UT. So today we are diving into the data manipulation language for MySQL. So today we're going to go over predominantly queries over a single relation. If we have a little time at the end, we'll just introduce the join operation, which is queries over multiple relations. Obviously, queries over a single relation are easier. And while the queries on the slides use the property management database from the book, most of the queries I'm going to demo today are actually interactive and from the schema that comes with that createdb.sql file. So a lot of today I'm just going to interactively demonstrate the queries through dynamic examples, but the basis for the relational query language is called select, project, join. So the select will filter rows in a relation so that you only return certain rows. For example, you just may want all the staff from branch B001 in the property management database. Project, by contrast, filters columns. So you might only care about the street address for the branch relation and may not care about the other columns. And then join is the way you connect information from multiple relations via foreign keys. So these are the three basic operations that you hear people talk about with respect to SQL databases, or actually any kind of relational database. And there are 4 key SQL DML commands. They are select for retrieving or reading data, insert when you need to add a new tuple to a relation, update when you need to modify one of the attributes, one or more attributes in a relation. So insert will actually add a tuple, delete will actually remove a tuple, update will modify an existing tuple. So these are the 4 commands. This is how you start any command where you're going to be doing some kind of manipulation. Okay, and you'll see that SQL, the query language is fairly verbose. It was designed for non-programmers. So for those of you familiar with C or C++, the terseness of it, you may be a little discombobulated by the verboseness of SQL. It's just something you need to get used to. So here, for example, you see insert into is actually the command for inserting a new tuple into the staff relation. You say insert into staff values and then the values. In C++, it might be far more succinct. It might just be insert staff and then a list of values to do it. So you'll just either memorize the syntax or you'll look it up on the internet, which is what I often end up doing. It's not always like insert. I always forget the into. It just seems ridiculous that I have to type into, but there you have it. So I type insert value or insert staff values. It doesn't work. I'm like, go and look it up. It's like, I forgot into. Okay. Case sensitivity. So surprisingly, most things in SQL are case insensitive. The only real exception is for literal character data like street addresses. And even in our version of MySQL here at UTK, even the literal character data is case insensitive. So if I do a query and I ask for the branch at 1678 and I capitalize everything, Cardiff Road, and in the database it's actually 1678 lowercase, and then we'll do an uppercase like that, it will still match because it's case insensitive. The only thing that our server seems to be case sensitive on is the names of relations. Oracle is a little more closer to the standard, so it's case sensitive for field names and literal character data, so closer to the SQL standard. I guess the bottom line is you just got to get used to the fact that almost everything in MySQL is case insensitive, even down to the literal data. Okay. When you're writing your commands, just try to make them readable. The book does a good job of indenting. So generally with SQL commands, they're going to require more than one line. Generally, you want each clause kind of starting a new line, maybe indenting things in a nice way, just makes it easier to read them. Don't worry about that. And okay, another thing, very quickly, got to get used to. Generally, you enclose literal data in single quotes, not double quotes. When you put something in double quotes, certainly in the SQL standard, it generally is referring to metadata in the database like an attribute name. So you can actually have column names with spaces. And the way you then refer to a column name that has spaces is you put double quotes around it. So when you're using your character data that you store in the database, you typically just use single quotes, not double quotes. So that's something else you need to get used to. And then I don't think I have it in the slides, but there's a new data type that you will be using, which is dates. Dates are pretty integral in databases. And the format of dates is year, 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 month, month, day, day. So for example, 2018, 08, 30 is today's date. And it's pretty strict about that. That's the built-in data type for dates in SQL. So don't go trying to roll your own, because things like SQL's inequality operators expect the data values to come in this format so that they can compare dates. Okay, so the relational operators like less than, greater than, equal to, they can all compare dates, okay, which is very nice. They know, but only if you put the date in the format that the SQL interpreter expects to see it. Okay, so the slides are handy for looking at syntax and the like, but I think in terms of presenting things, it's more interesting to actually dynamically create the queries and have you look at them. So first of all, if you're wanting to know what tables are in your database, there's a command called show tables, and that will show you the tables. So that create SQL.db command that's in my notes, it creates 3 tables called courses, student, probably should be students, because I'm going to constantly today forget to put that S, so I need to change that. And then student courses, which, let's just look at that. So back to show all the tuples in student courses. There's our first query. Select star. So star says I want to look at all the columns, and there's no filtering on the rows. So you can see it prints out a table, and you can see that basically that student courses, it's more like a transcript. It's what student took what course and what their grade in the class was and what their raw score in the class was. So student 1 took CS 140, got an A- with a score of 89. And if we look at the other ones, you put a semicolon to terminate the statement, by the way. If you don't, it's sitting there waiting for, it thinks there's more to the command. So semicolon terminates your statement. So the student relation, first name, last name, ID, and GPA. The courses, that's like our course catalog. So the course ID, name, and location. So those are the three relations we'll be using to illustrate our queries. Just like you had show tables, you can also say describe courses, and that doesn't actually show you all of the contents. Instead, it actually shows you the catalog or the schema. So this is actually the describe command. It actually is the schema. It will show you the schema for that particular relation. So course ID is limited to 5 characters. Null means that yes, it's optional, meaning I don't have to provide a value for it. And I actually don't have right now any key, so I haven't specified any attributes as being the key. The default value, if I don't provide a value for the field, is null, nothing extra. Don't worry about the extra field. Okay, so I said that the two big operations are project and select, at least on single relations. So the way that you specify or project, the way you filter columns is right after select, you show the column names that you want to see. So let's say in the course ID, I want or in the courses relation, I want to just look at course ID and location. So it would be select. Then I might on a different line say the from indicates the relation or relations. So in this case, we want it from courses. And we want to see all the tuples. So here it's just kind of a project. We're saying we only want to see 2 of the 3 attributes. And you'll notice that in the catalog, course ID was capitalized, but down here I did not capitalize it. And it's perfectly happy to give me a result. It knows what I was talking about. Okay? So now I may want to do, that was project. Now I may want to not look at all courses. Maybe I only care about the courses that are being offered in Glocker. So in that case, I would add from courses, I would add a where. So the where clause allows me to filter rows. In this case, I would say where location. And now notice I use a single quote, not a double quote. And notice I am not capitalizing Glocker, and it's not going to make a difference. It still came up with the 2 courses that are being offered in Glocker. Anyone notice a difference between this comparison operation and one in C or C++ or Java? It's not a double equals. Very good. It's a single equals. Okay? And if you're familiar with C and C++, the not equal does work, but it's not always in the language. Okay, so if you really want to be safe, you actually say not equals. Whoops, not? Really? No, it's not. Or maybe, maybe they're just not supporting it. Pardon?
Maybe not. Should be for location.
No. I just think that it's not using not, it's using the not equal. That's interesting. Oh, never mind. Not is not a Not is a Boolean operator, and I'm using relational operators here. So you do use not equals because that's the relational form of it. Not is a Boolean operator. I was ahead of myself. Okay, so here, anything that's not equal to Glocker. And it supports all the normal relational operators. So I could also find everyone in, so let's describe student. So I could select everything from student where I'll say the GPA is greater than 3.0. And it gives me everything where it's greater than 3.0. Supports all the relational operators. Now it also selects any Boolean operator. So now I just hit the arrow keys and it has a history just like Unix. So and GPA less than 3.5, and that's the empty set. Yep, let's do it less than 3.8. There we go. So everything comes out in a table. The result is a table. And we have or, so I could say select star from courses where, actually the where should have been on this line, but where location equals Glocker or location equals Ferris. Okay, you have to write it out. You can't say where location equal Glocker or Ferris. Just like in C++, you can't write it. You have to write it out. Yes.
Sure you can say where not location equals Glocker. Use not like that.
Yes, I could. So what it would mean, you're right. I see what you're saying. So if I said select star from courses where not location equals Glocker, it should also work because now it's taking the result of comparing location with Glocker and negating it. So you're right. That's a fine place to put the not. Yes, parentheses is very useful for specifying order of operations. In fact, I believe and has precedence over or, but I'm not even sure about that because I always use parentheses. It's been a long time since I haven't. So yep, definitely want to get used to using parentheses. So, but I guess what I was trying to show earlier where I can't in C++, this would be also what I would use for not, and that didn't work out so well. Okay, so in MySQL and SQL, the Boolean not operator is literally NOT. It's not a bang sign. Okay, now remember they want to make it easy for end users. So there's a couple additional things. You can say select star from courses where location in, and then I can give it a set. So Glocker, Ferris. So it's a comma separated list inside parentheses. And the parentheses is supposed to represent a set of values. So it gave me anything that was in Glocker or in Ferris. So it's in is like or, just a more succinct way or concise way of saying or. And I like it. I think it's a nice addition, but again, you have to remember the syntax. Same thing if you're doing range queries. So before I wanted to get all GPAs, a long time ago, there we go, between 3.0 and 3.8, I can also say where GPA between 3.0 and 3.8. And now it will give me everything between 3.0 and 3.8 inclusive. So notice here, this GPA is 3.0. It appears in the result. If there was a person, let's do 3.75, you'll see that it's inclusive there as well. So it's an inclusive between. Okay, but the between and in are syntactic sugar. You can do the same thing with in with a series of ors. You can do the same thing with between with a single and. If you are doing alphanumeric, let's say I want all students, select name from, actually it's last name, and I want all students whose last name starts with the letter M. I could say select last name from student, where last name equals, and now instead of using the wildcard character, you use the percent sign. So for those of you familiar with regular expressions, if you wanted it to start with M and then anything could come after it, you would use star, but in SQL you use parentheses for the same thing. It means zero, matches anything after it, 0 or more occurrences. So this will give me all last names that started with should have. Select last name from, there's a mouse in there. Is it really going to be case sensitive now? Okay. Last name equals, select last name, second, this is weird. Select star, no. Last name from student. There's mouse. Where? Oh, thank you. It's like. There we go. Like is what we use, not equal. See, you got to remember those things. Thank you so much. Now it works. So you have to use like when you're going to do your expressions, not equals. And you'll notice, is this a real relation? No, why not, Thomas? Yep. So in fact, MySQL results may not give you a actual relation. This is an invalid relation that comes out. It's okay because there's 3 M's. If you want to get rid of it, you say select distinct. And that will get rid of any duplicates in the output. Okay. You can also, it's much less common. You can put the thing anywhere. So I could actually say, let's say I wanted anything that had OU in it. Okay. So that's anything, matches anything before the OU, then OU specifically, and anything after. Yes? Pardon? Yes, because it's just, they're all the same. Distinct means that the tuples would be identical. So it doesn't matter which one it chooses.
So like if it had the same primary key, would it choose the first, like if you were only keying off the last name, would it only return one? Like if you had multiple people's last name?
Yes, it would only return. So if you had, because that's what I had. If you look at the mouses, let me just select first name, last name, where last name like M. Select first name, last name, where from. There's 3 different tuples, and then it just strips. When I do the select last name, it just strips the first name, so it ends up with 3 tuples. They're identical. So I guess I'm not sure what you mean by which.
Are they ID'd off of like the primary key?
No, there's no primary key here.
So will it just read mini mouse and that's the first occurrence of it, so it won't worry about the rest of them, or is it like the last occurrence?
No, generally it would actually. That's a good question. I think it actually comes down to how the query optimizer is actually implemented. So I think it's what you would call a implementer's decision. Because they may not know when they encounter Mickey Mouse that this Minnie Mouse has already been seen. So they might actually create all of the result relation, then sort it, and then eliminate duplicates, or they could use something like a tree or a hash table. So it's kind of up to the implementer how they do it. Yes?
Is there any way to like sort or like specify the sorting algorithm you want to use? Like for example, if you want to sort by alphabetical order.
Yes. Oh, no. You get to say whether it's in ascending or descending order, and that's it. So it will use its own, pardon?
So like if you have it check maybe the first character, but not like the entire thing.
Nope.
Maybe not. Okay.
That's, yeah, you can't, unlike C or C++ where some of the sort algorithms let you specify the comparison function, nope. So normally, if you want to do that, you'd download the result into a scripting language, and then you would do the comparison there. So yes, if I want to sort, so here we have first name, last name. Well, actually, let's just start by sorting. So I could say select star from student, order by, and that will order it by the last name. So now you can see it's in alphabetical order on the last name. Or I could say descending, DESC for descending. Haha, now my last name is first. Okay, you're allowed. So here you can see that the three mouses aren't in the order you would probably expect. You'd probably expect Jerry and Mickey to be before Minnie. So you can break ties by giving it a comma separated list. So the first one is the primary, so last name is the primary sort key. First name is the secondary sort key. So now everything comes out sorted the way you expect it to. Thomas, I think the reason that you can't specify the comparison algorithm, again, it was meant for end users and they're not that sophisticated. So you get defaults. Okay, so like is, so remember, because I just forgot, you can say select star from student where last name equals mouse. That's fine. It's just when you want to do pattern matching, now you have to use like rather than equals. Let's see. So that's that, and we went through and operators. Went through order by. We went through distinct. See if there's anything else that is of interest here. We can do calculated fields. So let's see. Not any real good calculated field here. But let's just randomly do one. So we'll say select GPA divided by 12 from, obviously that's kind of random, but from student. And there you go, it divided everyone's GPA by 12. And that's not a very, normally you wouldn't want to say GPA divided by 12, so you can say as and give it a better name, like as scaled GPA. So now, whoops, now it shows up as scaled GPA. So the as allows you to give a column a different name. I can even say select last name as L name, and it renamed the field. So I can even rename my existing fields if I want. Okay. Let's see. So let's say this would be pretty unusual, but just like you could say select say student, we'll say last name from student where GPA between say 3 and 3.75. I could also say where it is GPA is not, and then I'd get the opposite. So you can use not for negation. I hate not. I just don't think people think in terms of not that way, but there you have it. Okay. Now, let's insert. So we have let's do select star from courses again. And I'm going to insert into courses values, let's see, CS465, course name, I'll just make it simple, databases. And now I'm not going to give it a location. I'm going to give null. Remember, that's just an absence of a value. Okay, so if I now, again, look at it, there's databases at the end with the null value. Just a second. So, let's say I want to find all entries that are null. Maybe I want to clean it up, okay? It's not good to have null locations for things. So I say select star from courses where location equals, and I try null. Empty set. That's clearly wrong. Okay, there is something there. Same thing, just like had to be used rather than equal, it has to be where location is null. Instead of equal, which any logical person would assume, you have to use is. And this is one of the places where you may very well use not, because, for example, comments for viewing, you'd probably want to see all non-null comments. So actually, this is one common query, is not null, because you want to find only the tuples that have some value in that field. Yes. Okay. Yep. So when you're looking for nulls, you have to use is null or is not null. Again, you just have to memorize it or look it up. It's just kind of a pain in the ass. Okay. And we went through order by. Okay. So those are the simple queries. Now, you sometimes want to be able to aggregate information. So for example, I may want to know how many courses we're offering. So count star will count the total number of tuples in my relation. And of course, count star might not be exactly the most mnemonic, so I might say select count star as num students. So it gives me a count. Or I could see how many students, count star from student where GPA greater than 3.0. So we want to see if we have grade inflation. So we see we have 5 students whose count is greater than or equal to 3.5. So this is called, count is called an aggregation operation. And there are 5 aggregation operations. There is count, min, max, average, and sum. And they do exactly what you would think. Min returns the minimum value for an attribute. Maximum returns the maximum. Average takes the average of a column of numbers. Sum takes the sum of a column of numbers. Count, min, and max work with alphabetical data, but they don't work with numeric, they work with all data, essentially. Alphabetic, numeric data, dates. Average and sum, as you might expect, work with numbers, but not with dates or with alphabetical characters. So before I forget, I'm just going to go back for a moment. Dates. You're going to deal with dates a lot, okay? And dates, you can actually say stuff like select. I don't have any dates right now, any columns, but let's say in bookings I want to select star from booking where date from, and I could say between 2017 or 2018 08 30 and 2018-09-30, and now it would give me all bookings in that range. So you can do nice computations with dates, yes.
Does it register that as just a string, or is the date some sort of special?
It's a special value. It's not a string. It's a special value. Okay. Now, actually, I probably need to check, because I did not, whether I need to put those dates in single quotes or not, because I'm not 100% sure on that. So they maybe belong in single quotes. But at any rate, you're able to, or I can say where date from is less than 2018-08-30. And now I'll get all dates less than that. So you can use your comparison operations with dates, which is very handy. And I actually didn't come prepared to talk about that, but it seems like a good time, so I'm going to Google it. So SQL date adding. So you can see there's a number of functions that actually allow you to do things like add. Here I'm adding one to a year, so it's actually would come out as 2018-825. Or if I just didn't specify this, it would add one to the day. It'd become 826. And there's other ones for date. You can subtract dates. So this seems to be just for, so let's do date diff. I think it's date diff. SQL. Yep. So if you want to get, for example, the number of days that someone stayed in a room, you could actually use the date diff function to take the date. You could say something like select star from booking. Whoops. What is it going to be? So maybe select star from booking. We might want all things greater than all stays greater than 7 days. So I might say date diff date from. That's wrong. Date to date from, because date to is later than date from, and that would give me all the reservations that were longer than 7 days. So there are nice operations, especially date diff and date add, that will allow you to add dates or take the difference between two dates. And in fact, in homework 1, I think you're actually sometimes asked to calculate how much revenue we get from a customer. You have to use date diff to do that, because you have to know how many days they stayed at the hotel. Okay, so in that case, you might actually have something like, again, you might have select date diff. Not going to worry about that for the time being. Too much information. But the point is, you can do arithmetic operations on dates using the appropriate functions. And I think, let's let's do something here. I'm actually going to bring in the information for homework 1. I think it's hotel.sql. There we go. So now we have booking. Okay, whoops. So that's the one time when you have relations, that's the only time that case matters. So here's our bookings. So let's actually do one of these. Select star from booking where date from is greater than 2018-09-01. There you go. So I didn't have to put literals in there. Also, though, just a second, date from, oh, wait a minute. Anyone notice an issue? It's not right. I got this in here, so let's try literals. There we go. So you do need to use literals for dates, otherwise it won't come out correct. So, okay, now what I wanted to check out, I wanted to see whether I could just add one to it, where date from is. So now I want everything after 9/16. See how this goes. Nope, it didn't like to add them. Okay. Now let's do date add. Really? Date add doesn't exist? I don't believe it. Okay. Yeah, I do have two semicolons, but I don't think that's the issue. I think it's not okay. I have to figure out what the date add function is for my SQL, because it does not appear to be the same. Well, let's just try this. Let's actually see if it's because I'm not. Am I? Date add? Oh, really? Well, that's different. Okay, thank you. We'll see. Yeah, that's what I'm wondering. Day 15. Unknown column now. Sure, data from is bad. Nope, still not liking date add. It says, okay, I will figure that out. Try. Nope, doesn't like that either. Now you have an error in your SQL syntax. Okay.
So the one I've got has date underscore add, and then the date, comma, all caps interval, and then the value and the unit.
Ah, thank you.
Comma interval, and then
Yep, and then 15.
No commas after interval. Sorry.
Okay.
And then you need the units, so like days or seconds or whatever.
Really?
After, yeah.
We'll check it out afterwards. Don't worry, I'll check it out afterwards. Clearly, there seems to be some difference between the SQL standard and MySQL. I believe in the homework assignment, it may even tell you what to do. So I will get back to you on that via Piazza, but there is a way to add dates and take the difference between dates in MySQL. It's just obviously I'm not getting it right now. Okay, so getting back to what we were talking about the aggregation operations, min, max, and so on. So I can say select min GPA, max GPA, average GPA from student, and it gives me that result as an aggregation. Now, you might want to be able to do this. Select last name min GPA from student. And you would think this might give you the last name of the student with the minimum GPA. Okay, let's see if that's correct. It's not. Oops. Told you that it would trip me up. So the lowest GPA belongs to Bugs Bunny, not to Van der Zanden. So many SQL interpreters would just give you an error here because this is actually not a legal query. So when you do an aggregation operation, you're not allowed to include other column names with it, which is kind of a pain in the neck. You actually would like to know what is the last name and first name maybe of the minimum GPA student, but that's just not something that SQL allows. You can see MySQL executes the query, but it just takes as last name the first name that it finds in the relation rather than the last name of the minimum GPA. So how do we get around that? Because clearly, so now you think, okay, why don't we do this? Select last name from, let's do also first name, from student, where minimum GPA, now we know that the minimum GPA, or where GPA equals the minimum GPA. Seems like that should work, right? Reasonable? Not allowed to use a group function in a where clause. So you cannot use a group function in a where clause, which is also a pain in the neck. So how the heck are we supposed to do it? The answer is you get variables in SQL where you can store things. So if you put an @ sign before something and then you use the colon equals, this will temporarily store min GPA in this variable called @min GPA. Now I should be able to make sure I did that correctly. Select last name GPA from student where GPA equals @GPA. Somehow I knew that. Oh, minimum GPA, thank you. There we go. Now we get the right result. So you can use these @ variables to store a value. You can't use them to store a relation. So if I tried to use it to store a relation, it would not work out. But you can use it to store single values and then use that later. So that's how you get to use the value in a query. Actually, there is another way. So there is subqueries. So you could say, I believe, let's see if this works, where GPA equals select min GPA from student. I think this is going to work as well. So that worked as well. So this is what is called a subquery. And that subquery is returning a single value, so you can also do it that way. Just a pain in the neck, but you just have to go with the flow, and that's what it is in SQL. So you can either assign that result to a temporary variable, or you can use it in this subquery form, whichever floats your boat. I don't care what you do. Okay, both are good. Okay. Now, when you are doing it, count will count the fields that have nulls in them. So if I say, going back to courses, Okay, there's a null in the location field. I could say select count location from student, and it comes unknown column from courses. Thank you. Actually, interesting. It filtered out the null. That's interesting. I didn't think count filtered out nulls. But it filtered it. Okay. Weird. Huh, okay. At any rate, I have to go back and look at it. Min, max, average, and sum will filter out nulls. Makes sense, right? You don't want to do anything with a field that is null. So if you are doing, say, a calculation for salary, and if there's a null value for that salary, it will be excluded from the calculation. Okay. So we've got aggregate operations. We've seen how you can not use an aggregate operation in a where clause, but you can if it is returning a single value. Just to further show you how sensitive it is, here we said where GPA equals select min, but let's say we switched it up. Seems like order that the comparison should be commutative, right? Oh my gosh, that worked. That's not supposed to either. Okay, so in the SQL standard, you can't put the subquery on the left-hand side, but clearly in MySQL, they're letting it happen. But that is supposed to be a restriction on queries, is that you can't put the, so if you want your code to be portable, you have to put it on the right-hand side, the subquery. Okay. Now, let's go back and look at student courses, something we haven't done much with. Okay, so here, that's not student courses. There we go. So let's say we want to know what was the enrollment in each of these courses. So that's an aggregation operation, but the problem is we don't want to count the number of tuples in the entire relation. We want to count all tuples that are CS140, all tuples that have EE300, all tuples that have AC102. So we want, in effect, to group our rows together by a certain value, in this case the course ID, and there's a way to do that. It's called grouping. So we can select, let's see, course ID, count star as enrollment from student courses, group by course ID. And now we get the enrollment in each of the courses. So what the group by clause is doing is it's saying I want to basically order these rows into sets based on some attribute value. Okay, so this is, and then you'll notice that I was allowed to use the course ID now. Before I couldn't. The difference is that when I use a group by clause, any attribute that appears in the group by clause is now allowed to appear up in the select statement. which makes sense because you're grouping on that attribute. Okay, before you weren't. Okay, so let's say now that we want to find out our low enrollment courses. We'll define low enrollment as any course with 2 or fewer students. So we can say group by course ID having count star less than or equal to 2. And now we just get those 3 courses. So we did not use where. We used having. You use where with single rows. You use having with group by. So having is like a where predicate except on the aggregated results of a column. Okay, so if I tried to use, please don't make a monkey out of me, but this should not work. Where count star, thank you, it did not work. So when you are allowed to use aggregation functions in having, but having must be used with group by. So having is basically a way of filtering out your grouped attributes. Okay, so questions about that. The group bys are very handy. It takes a little bit of getting used to them. I think I got everything that I wanted to say about them, so let's just make sure about that. Get down here to group by. Oh, still join. Multi-table queries. Ah, yes. Something I please don't do to me. Notice that here, so here I am selecting the branch number, I'm counting the number of staff in each branch, and I'm taking the sum of their salaries. And I group by branch number, and then I order by branch number. In homework assignments, I say sort the result by something, and I get people using group by rather than order by. And it works, which just pisses me off because it's not the right sorting command. If you want to sort something, you say order by. Group by is not meant to organize things into sorted order. However, guess what? The side effect, how would you normally do a group by? You would probably sort, right? Because you have to bring all the rows with the same value next to each other in order to do your computation. So the query optimizer, when it does a group by operation, it typically sorts on that field. So when it produces the results, it just so happens that they come out in alphabetical or numerical order as a side effect of the implementation of the query optimizer, which is it sorted that column in order to do the grouping operation. So students get suckered into thinking, oh, group by sorts. Well, it doesn't have to. It just so happens that it works for MySQL. So bottom line, if I tell you that something should be sorted, use order by. And if I say that I want to get the counts and sums for the branches and then it should be ordered on branch number, please group by branch number and then also say order by branch number. Don't just assume it will come out sorted just because you group by branch number, or you'll lose some points on a test. Okay, I think that's the only big thing. If you have nulls, they end up being equal when you're doing group by statements. Generally, you don't worry too much about nulls, but they can come into effect like when you're counting the number of views for a property. That could be an issue. Okay, that's the end of aggregates. Before I go into joins, so take a moment, deep breath. I am going to go back for a moment to the lecture, not that one, to the lecture on chapter 4, because I want to go over the date data type, and I think I have dates here. No? Oh, I know where I have them. It's going to be chapter 7. But I kind of want to cover them right now because I think it's handy. There we go. Dates. Because you're going to run into dates in your homework assignment, and that is the slide. Okay, so it does turn out that date add is date underscore add from MySQL. So there's actually 3 types of dates that you get in SQL. The type I just told you about, which is a day. You also get a time in hours, minutes, seconds. And you get a timestamp, which stores a date and a time. So it's a combination of the date and time, and you put them in single quotes. And then here are some handy date functions. If you want the current timestamp, that's the now function. The current date returns the current date. Current time returns the current time. Date will extract the date part of a timestamp. Date add will add a date to something. Date subtract will subtract an interval. So this is what the person was talking about earlier. They referred to intervals of time. So date diff would be the number of days between 2 dates. Date add will add an interval to a date. Date subtract will subtract an interval from a date. Okay, and intervals can be some kind of time interval. It can be a year. So you can actually specify sometimes when you're declaring something what the interval is. So this says it's a year to a month, which means that the interval for this particular field would consist of a year and a month. Okay, this interval right here consists of hours, minutes, and seconds. And it can have up to 2 digits for the hour and up to 4 digits for the decimal point after the seconds. So an interval is also a type in SQL, and for the first homework assignment, you care about intervals because sometimes you'll be asked to compute the number of days a customer stayed, and that's the difference. That would be date diff. It is the difference between the date from and date to fields. Okay, so that's introducing this a little early. This is in chapter 7 if you want to know where it is, but that's some handy information about dates. Any question about dates or intervals? Okay, and you will probably have to look up on the internet the exact format of date add, just as I'm going to do after class to see why I was messing it up. Okay, the book is not going to have it right probably because it appears that the MySQL version of date add, date sub, and date diff is different than the SQL standard. Okay, now just quickly looking ahead, I won't get deeply into it, but what we talked about today were queries on a single relation. but very often we want to get information from two or more relations, and to do that, we need to do what is called a join operation, where we join two different relations, and then we get information from them. So for example, here, if I select, let's say I want all people, so select star from student courses, where, what is it, grade, I think? Yep, grade. So I want all A's, so I'm going to say like A and then anything after it. That's nice, it gives me all the A's and A minuses, but that doesn't give me the names of the students. So if I want the names of the students, that's obtainable. If I look at the student relation, you can see that here's student ID, here's student ID. So the student ID is called a foreign key, and we can use that foreign key to look up the name in the student relation. So we can say select, let's go back. So maybe what we want, whoops, there we go. Let's say we want the first name and last name, and we want the course, so we'll say course ID, and the grade. And now we want it from student courses and students, or student. And now it is still where grade like A anything, but now we have an and we say student courses dot student ID equals student dot ID. Sure that's right. Yep. So what we're doing here is same thing, except now we're selecting these fields from the student relation, these fields from the courses, student courses relation. We still want the grade to be like an A, and in addition, we want to pick up the student's first name and last name. So when we find the student ID in student courses, we want to match it to the student ID in student. So now we have all the courses that were taken by the different students and their actual names. So that's called a join operation. It's operating on multiple courses. So next time, which will be Tuesday, we will be going into all the different types of join operations that you can perform on our relations. And if we get to it, we'll get to subqueries. We may or may not get to subqueries. So the quiz, we have a nice Labor Day weekend. The quiz, don't forget about it. Make sure you do it. So, and probably a good idea to at least start looking at the homework assignment as well, even though I don't think it's due until late next week. So have a great Labor Day weekend, and I'll see you on Tuesday.